Hello everyone, welcome back to a new video. So in this video, we'll be solving some more questions related to arrays and vectors. So without further ado, let's get started. So the first question that we have here is to remove duplicates from sorted array. So we'll be given an integer array nums which is sorted in non-decreasing order. So what do you mean by non-decreasing order? An array is said to be in non-decreasing order if our current element is greater than or equal to our previous element. So this is the condition. If this condition is holding true throughout the array, then our array is said to be in non-decreasing order. So we have to remove the duplicates from this array in place such that each unique element appears only once and the relative order of the element should be kept same. So this is the condition that we need to take care of, and we have to return the number of unique elements in the nums. So while returning the answer, we need to follow following things. So we need to change the array nums such that the first k element of the nums should contain the unique elements in the order they were present initially in the nums. And we are not concerned with the remaining elements of the nums. So let's have a look at the example. In the first example, our array is containing elements 1, 1 and 2. So as we can see, here are only two unique elements, which is 1 and 2. So we need to return k equals to 2, and we need to arrange the elements 1 and 2 at the start of the array. So let's have a look at another example. In this example, so as you can see, there are only unique elements such as 0, 1, 2, 3 and 4. So here number of unique elements is equals to 5. So we need to arrange these unique elements at the start of the array, and we need to return our answer as 5. How can we solve this question? So as we have to return the number of unique elements, and we need to rearrange the unique elements at the start of the array in the order they were initially present in the nums. So can we use some extra space to store the unique elements in the order they were initially present in the nums? So yes, we can use the data structure something like set. So what is set? So set is a data structure which is present in the C++ library, and which is used to store the unique elements, and it stores the unique elements in sorted order. So as our array is sorted in non-decreasing order, so it will be helping us to maintain the relative order of the elements. So let's suppose I'm having an array which is consisting an element 1, 1, 2, 2, 2, 3, 3 and 4. So what I will do is I'll iterate from the first element from the array till the last element. And while iterating throughout the array, I'll insert the elements into this set. So let's suppose this is my set data structure. So let's start iterating the array. So currently I'm at element at index 0. So I'll insert that element into the set data structure. Now I'll move ahead at the index 1. So at the index 1, element 1 is present. So as element 1 is already present in the set data structure, so we'll move ahead. Now I'll go to the element 2. So I'll insert it to the set. Now I'll go to the next element, which is again 2. As 2 is already in the set data structure, so it will not be inserted into the set. So as our next element is also 2, so it will be also not inserted into the set. So we'll move to the next element, which is 3. So 3 is not there in our set data structure, so it will be inserted into the set. The next element is also 3, so it will be not inserted into set, and we'll move to the next element. So our next element is a 4, which is not present in this set, so it will be inserted into this set data structure. So after iterating over these array, our set data structure will be containing the unique elements, which is 1, 2, 3 and 4. 1, 2, 3, and 4. So we'll be storing elements from the set data structure and we are not concerned with the remaining elements. So my array will be looking something like this. These are my unique elements and my k is 4. So I'll be returning k equals to 4. So let's see the pseudocode for this approach. So we'll need an set data structure which is of type integer and which is used to store the unique elements. So let's name it as S and we'll need to iterate through the array. So we'll start from index 0 and we'll go till the I is less than r size of the num. So let's suppose my n is denoting the size of the array and I'll keep on incrementing the r. Now I'll insert each element from the nums into the set. So s dot insert nums of I. After inserting the elements from the nums into the set, my set will be containing the unique elements. So as I need to return the number of unique elements, so we need to store the number of elements somewhere. So how can we get this? So we can easily get the number of unique elements by accessing the size property of the set. So I can store it in the variable k. So k will be s dot size. So it will be storing the unique elements. Now I will iterate over the elements from the set data structure and I'll restore them into our original array starting from the zeroth index. So let's take int index as 0 and we'll increment our index as we go on through the nums array. So for elements in our set data structure, what I'll do is I'll store the element into the nums array at position index and I'll increment it. So after iterating through the each element from the set and after restoring it into the nums array, our unique elements will be stored in the nums array from the starting and we can simply return our key. Return key. So let's talk about time and space complexity for this approach. So what will be the time complexity for this? So as we are iterating through our nums array, so this for loop will be taking big O of n, where n is the number of elements in the nums. And after that, we are again iterating over the number of elements in the set data structure. So this will be taking us big O of k, where k is the number of elements in the set. And for the insertion in the set, it will be taking us big O of log n. So the overall complexity is big O of n log n plus k. So this is our time complexity. What about the space complexity? So talking about space complexity, we are consuming this extra space to store the unique elements. So my space complexity will be big of k, where my k is number of unique elements. So this was the brute force approach for this. So can we optimize this? So yes, we can optimize this if we can somehow get rid of this extra space that we are using to store the unique elements. So we can optimize this approach. So let's have a look at the optimal approach for this question. So